This assessment asks us to draw two chair conformations for the molecule on screen. We can start by drawing the first chair conformation and putting the tert-butyl group in really any arbitrary position. Let's do that. So we'll start by drawing our chair. Again, keeping all of our lines parallel. And then we're going to put the tert-butyl group. We can put it anywhere. Let's go ahead and put it in the axial position at this carbon here. We'll label this as carbon 1, and let's go ahead and number around the ring 1 through 6. If the up substituent at carbon 1 is axial, the down equatorial substituent will be a hydrogen. We'll put that in there just to help us make sure that we have the right next structure. At this point, we're ready to do the ring flip, and what we're going to do is we're going to bring flap 4 up while at the same time bringing flap 4 down. That was why we numbered the carbons, so we'll draw our flipped chair next. Keeping the numbering the same, 1, 2, 3, 4, 5, and 6. What you notice, carbon 1, that was the up flap, still has two substituents, but now instead of the axial substituent being the up substituent, now the equatorial substituent is the up substituent. And so that's where we will put our tert-butyl group. What was the equatorial and down substituent is now the axial and down substituent. And so this represents the two chair conformations of tert-butyl cyclohexane. Which one is most stable? The most stable one is going to be the one that has the large substituent in the equatorial position. So the more stable conformation is that.